Hello everyone, this is Mohammed Yaqub and I am showing up again on YouTube to share with you an application that I have developed recently. And that is how to play a WAV audio file from USB drive out to the audio headphones. And as you know, STM32 HAL Discovery features an audio codec that we can use to play an audio out, and also USB to plug in a USB drive. All right, so I have to say that I had lots of fun preparing this video, and this is the ultimate fun moment. Let's share it together. The very first thing we're going to do is to open CubeMX and set up our pinouts, and then we're going to jump into STM32 Cube IDE to carry on the programming. And for this tutorial, I've created about 4 files. There's 2 libraries and the audio CS43L22 that I've already shared previously on YouTube. I've previously shown you how to play an analog pass-through and a generic I2S signal. This time we will utilize that audio library to read a WAV file from USB drive and play it out in the headphone. Okay, so what you want to do is to go to Access Board Selector. Okay, now we need to select our board. So it's the STM32 HAL Discovery. You want to select it and set up the pinout. I don't want to initialize to the default mode. Alright, now the first thing I want to do here is that I want to clear all the pinouts, and let me walk you through the user manual of the discovery board just to give you an idea of what are the sort of pins we need to set up for this tutorial. So let's head to the user manual. I'm going to be using USB, so if you navigate down to page 35 of the user manual, that is the USB on the go fast speed. And here, there is one required pin that I need to enable. So PC0 is a GPIO pin that I need to enable. This is the power switch on. This switches power to USB. And since we're going to use USB in host mode, which means we're going to plug in an external device, a USB drive, which require 5 volt power. And that's what this PC0 does. So in CubeMX, we want to set PC0 to GPIO enable it and set it to low because it's an active low enable signal. And then we want to enable USB interface, and that's PA11 and PA12, in addition to the V bus on PA9. So that's about the USB. Let's go ahead and set it up together, and we're going to come back again and look at the audio schematic. Alright, so that's quite simple. You want to go PC0, set it to GPIO output, and by default it is set to low. So this is already low, so now power should be enabled to our USB connector. Alright, now next thing I want to do is to enable USB. So if you head down to connectivity, I believe, and USB on the go FS, it's a host mode, and activate the bus. And you can see PA11, PA12 and PA9 are enabled. So that's awesome. And regarding parameter settings, we're not going to change anything on here. Okay. And the next thing you want to do for USB is to head down to middleware. We need to enable USB host. So USB host, set it to mass storage host class because we're going to read files from it. It's like a USB drive. Okay. Parameter settings, we're going to leave everything as default. The next thing we need to do is to enable a FATFS file system for it. So using the USB disk. Okay. And next thing we need to do is for the audio library. So let me head back to the user manual. Now on the user manual, if I scroll down to the audio schematic, or maybe scroll up instead, let's have a look. Here we go. So this is the audio schematic, and you can see we've got few pins here. The very first one is the I2C to communicate with the audio device, and that's on PB6 and PB9. So back on CubeMX, so we need to set PB6 to I2C1 serial clock and PB9 to I2C1 data. And on connectivity, I2C1, we need to enable it in I2C mode and leave everything else as default state. Then we have BD4, which is the reset pin. This is used by the audio library to activate and deactivate the audio device. It's like a hard reset. And that's on BD4. So we want to enable BD4 and set to GPIO output. And then we need to enable the audio interface line. So that's on I2S 3, I believe. And those are PC7, PC10, PC12, and PA4. All right, so we're going to enable it automatically, and let's see if it's going to enable the correct pins. Right, so we're going to head to multimedia, and I2S3 need to enable this as half duplex master. And let's enable indeed PC10, PC12, PA4. So let's double check again. So we got PC10 for serial clock, PC12 for serial data, and PA4 forward select, and we're going to need to enable master clock on PC7. Okay, so when you head to this, you can check master clock output, and it is indeed on PC7. And then the next few things we want to do is we want to enable the LEDs on the STM discovery board. So PD12 to PD15 are the onboard LEDs. And I believe you're already quite familiar with this. And PA0 for the button. I'll use button in my application to demonstrate how to play an audio, pause and resume, and stop it completely, and so on. We can use the push button for that. Right, now we need to do quite a little bit of clock settings to set up clock correctly for I2S. So we want to head to RCC first and enable the external oscillator. And that is enabled on PH0 and PH1. And now on clock configuration, we want to set this up. I am using the external oscillator, and I want to set the maximum clock speed of 168 megahertz. And now the important one is the I2S, we need to feed it 1 megahertz, because in my software, I assume that PLL I2S input is 1 megahertz, and I accordingly change the prescaler and divider to achieve the correct I2S clock. All right, so we want to set this to 8 and multiply this by 2 so that we retain the same maximum clock speed. Here we go. All right. And I want to set this to, I want to change this. I've got an error here. It's currently set to 50, which exceeds the limit. So I'm going to change the prescaler to 271. So that's something that gives me about, and I set the divider to 8, I think. 6, that gives me 45 megahertz. So that's a good initial value, but that doesn't matter as long as the input is 1 megahertz and this is a valid output. It doesn't matter at this stage because I already changed it in my software based on the WAV file sampling frequency. All right, I hope that makes sense. Now we're gonna head back to I2S settings. So on I2S, let's see if everything is okay. So I'm assuming 16 bits data frame, and let's select the initial audio frequency to 44 kilohertz. Okay, and that's pretty accurate. That's 0.24%. But in software, everything gonna change as I said. And then I want to enable DMA for I2S transmit buffer, because we're going to use DMA to transmit the audio buffer out to the headphone. So on DMA of I2S, select SPI3TX. And now the reason why we have SPI here and not I2S is that in STM32, SPI and I2S share the same data buffer and same hardware pretty much, okay? But it's the same thing. And for DMA mode, I want to set it to circular and use a FIFO with a full threshold, and the data width are half word because we're using 16-bit I2S, so that's a half word. And full word is 32 bits on STM32. Okay, and that's pretty much everything. These are all the settings we need to do for I2S DMA. Alright, and that's everything we need to do on pin configuration. Now we're ready to generate a project. So on Project Manager, give the project a name. I will call it WAV Player Tutorial. And I want to select the right folder to store in. So I want to store it at this very location. Yeah, I think that's the correct location where I want to store it. And the IDE, I like to start with System Workbench for STM32 instead of Cube IDE, because for some reason my Cube IDE is not stable with this. So I'll select System Workbench. You can select any IDE that works for you. It doesn't make any difference, okay? But I'll be using Cube IDE. I'll export it to Cube IDE. And I want to change the minimum heap size to 0x 2000 in hex, because my application requires some dynamic memory allocation and we need to ensure it's sufficient. And same thing for stack size. And that's it. And I believe this is the right firmware. Let me just double check this is the firmware I have. No, I want to use firmware 1.24.1. You can use any firmware you like. It should work the same. As long as it's a recent firmware and a stable one. Okay, now let's generate the code. And that says, no, I would have to change this. So let's redo that again. It will work. There we go. And I click yes. I'm going to wait for it to generate the source code. All right, and now we're going to head to open folder and copy project path. And I will open STM32 Cube IDE. I'm going to use a Cube IDE for this. Quite a lot of people now use Cube IDE and I like it too. I used to use System Workbench. Now I'm switching gradually to STM32 Cube IDE. It's a very, very nice tool. Okay, so heading to STM32 Cube IDE, I'll click on File, Open Projects from File System. I'll give it the path of the project. I'll click Finish. Now it will have to do some conversion to convert it to Cube IDE format, but that's fine because when I use Cube IDE, the raw format, it seems to crash for me. I'm not sure if I'm the only one having the issue, but using it this way, there's no problem at all. It will work the same. So let's wait for that to finish. All right, it finished exporting the project to Cube IDE, and now this is my WAV Player tutorial, and you can see it's an empty main, has got only the setup by CubeMX. Now let me build the project just to ensure things are okay. And now what you want to do is that these are the library files that I will share as part of this tutorial. So this one, the CS43L22, I've already developed this and I share it in a previous tutorial video. I've just made slight modification to it regarding audio volume. So I might update it there too. And these are the new libraries that I've written this time. I've written an audio I2S that controls I2S configuration like sampling frequency, starts DMA transfer and stop that. And WAV Player is responsible for WAV file format, reading from USB disk, and making all the required configuration for a WAV file. We're going to see that in detail in a bit. So what you want to do, I'm going to share these down in the description of the video, and I believe for this tutorial, I might share the entire GitHub repository for this project to make things easier for people who do want to start from scratch. But I highly recommend that you do start from CubeMX and do the things step by step, because this way you're going to learn. And feel free to discover the libraries here. And my main reference into developing these libraries are STM32 examples. So in ST examples, they provide example of playing a WAV file from a USB disk to the audio headphone, and I've used that example to make a much simpler version of their libraries. So that's my main reference into this tutorial. All right, now what you want to do is that you want to copy the audio folder into our WAV Player tutorial project. So I want to just copy it here. Okay, and now I need to add a path to it and include it as part of the source folder. You'll see it doesn't have the C sign, which means compiler doesn't compile this folder. So what you want to do now is to right click on this and go to properties, and on here under C++ general, go to paths and symbols, and the first thing I want to do is I want to add a path to this folder. So click on add and add audio, so that all the H file are built and compiled. And same thing on source location, add a folder and add our audio, and that's it. Now it should change and should have the C sign on it. There we go, as you can see here. All right, so now what we want to do is that I want to start including files into my main. So as a step one, I need to include my audio I2S and my WAV player, and at the same time my CS43L22. So I want to include all these H file into my main. Okay, so let's do that. And you can click Control Space to automatically write that. And the other one is my CS43L22, sorry. And the WAV Player API. Okay. And then, if you can recall from our USB flash drive tutorial, we need to export the application state because we need it when we initialize USB, and if we want to know whether USB drive is connected successfully or disconnected or it is ready to be used. And we do that by going to USB host, and it's rather USB host.c, and there we see this variable application state. So you want to copy this into our main as external. So I'll put it here. It's an external variable so that compiler can see it and add it to our main so that we can use it. All right. And then what you will do is that I'm going to set up my audio codec first. So these are things like initializing the audio codec, setting volume, and enabling right and left. So let's do that. And this is actually quite similar to my audio tutorial previously. So first, I need to initialize the audio codec. And I'm going to do that in bigger number 2. That's the ideal place for it after all peripheral initialization. And this function require an I2S handle and the output mode. And I want my mode to be I2S. And you can see that when you navigate to mode, you have I2S or analog pass-through. In our case, it's an I2S. So let me copy that. So the first one is Hi2C, handle is I2C1, and the other one is mode. All right, so let me copy this. This is I2S. And then we're gonna set volume. As I said at the very beginning of the video, that I made a slight change to the volume, to the set volume API. So what this does now is that this is from 0 to 255. 0 correspond to mute and 255 correspond to maximum. But trust me, you don't want to use 255 with a headphone. It is super loud. So I think you start with 150 is a good starting point. And then when enable right and left, I'm just going to copy it over from my note. It's way quicker. So enable right and left basically means you enable both right and left of the headphone. Okay. So that's it. That's all for the initialization of the audio library. And now let's initialize the I2S library. Now let me give you a brief description about this library and what it does. So the Audio I2S API library does things like starting the DMA, the I2S DMA, changing the system clocks, the BLL of the I2S, so that it matches with the WAV file sampling frequency. So the magic it does is that it changes the I2S clock frequency to play different sampling frequency depending on the file that we read from USB drive. Okay, so that's what it does. And we can use it to also start the codec. So instead of starting each of them separately, we can just call display. It will start the codec and also start I2S DMA transfer. Okay, and I'll leave that with you. You can look at it in details in your own time and find ways to perhaps improve it or make changes to it. But this one pretty much, you might not make much changes here. Okay. So to initialize this, I need to call its initialize function and pass in, I need to call the set handle rather, and pass in the I2S handle that contains all the configuration of our I2S. Okay, so we're going to call it here and pass in a pointer to the I2S initialization handler. Okay, and then what we want to do next is to start developing our application. The first thing I want to do is that I want to test my USB connect and disconnect functionality. So to do that, I will use the application state variable. So this particular one, if you can go there, you can see that it has got all these enum state. So I want to check if my USB is connected, then I want to turn an LED on. If it's disconnected, I turn it off. So that's the very beginning to ensure our USB library is working fine. And then we're going to move on and start implementing the WAV Player functionality. So if application state is, if this one is equal to, what's the state? Start. If it's equal to application start, then I know my USB is plugged in and is being processed and opened, and then else if state is equal to disconnect, mean disk is just being unplugged. So if this is equal to disconnect, then I want to turn LED back off. So let me just copy it over from my notes. There we go. So I set green LED and I reset it where USB is unplugged. So let's compile the code and look over into our STM discovery board and just double check that things are actually working on the USB side as we expect. All right, awesome. We know that our USB is working fine. Okay, then next step what we're going to do is that to mount our USB drive into a file system, and we're going to start implementing our WAV player. Now my USB drive has got a couple of WAV audio files that I stored at this file path. So let me copy it over from my notes. So private variables, I define this to WAV file 1, and the path is in audio directory, and it's called iraqi2.wav. Okay, so that's a very nice music. Then what we need to do next is that to check if application state is ready, which means that USB drive is ready to be used, not just at the start state, but in the ready state. Then I want to start implementing my application, and I'll show you all the fun of playing a WAV file. So if application state is ready, first thing I want to do is to mount my USB drive to file system, and you do that with if mount, and I only want to do it once, so let's do this. So if mount, and you need to pass in the FATFS variable, and you will find it in if you go to middleware, ST, I think third-party FATFS, it's basically fatfs.h. You just navigate there, and you'll find the variables that I can use as an extend. So the first variable is the FATFS file system. So let's use that, and it needs a pointer to that, I believe. Exactly, and then the drive path, and whether we're going to mount it immediately or just do that on the go. So let's do that. So that will be our USB path. You'll find it in the FATFS. Let me copy it. And it expects a constant tchar type. It's the same thing, but let me typecast it just in case. Tchar pointer. And I pass in the USB path. And then write 0 here. And I only want to do this once, since application ready will keep looping into my while loop, but I only want to mount SD card once. So I'll just add a Boolean variable for simplicity and call it is SD card mounted. And I'll set it initially to 0. And I want to check for this condition in my application ready. So that's a very simple implementation. You can do way better if you have an RTOS or things like that. So if SD card is not yet mounted, so if it's equal to 0, then I will apply this code and I will set this variable to 1 so that it doesn't enter again here. Okay, so that's step 1. And then starting with the fun. Now, the way I want to implement a WAV player in a very simplistic way, I have only a single push button on the STM32 discovery board. And what I want to do is that when you first press the push button, it starts playing the selected file. And when you press it again, it pauses and resumes. So any press will be pause or resume. If you hold the blue button while on the paused state, if you hold it for half a second, then it's gonna stop the folder. And you can start again by pressing to play the audio again. I hope that is not confusing, but we're going to see this anyway. Right, so step 1 is whenever my push button is pressed, I'm going to use a condition like this. If HAL GBI is a very simple pin read, if my PA0, which is the blue push button, is high, then I want to set the orange LED on, and I want to wait for half a second just to allow a delay. Just a little bit of delay without having to get this condition so often. And then step 1, now we're going to use our WAV player. That's the fun bit. So this is the WAV player library. Let me give you a quick walk through this library. So what this does is that it has a WAV header which reads the first 40 bytes or 44 bytes of our WAV file that we read from USB drive, and it specifies what are these parameters so that we can set our system accordingly. Things like sampling rate is very, very important. Okay, here we go. Now, the first thing we need to do is to select the file. So file select, we're going to call this file select simple function. I've created this WAV player in a very simple way. You can go through it if you want to make changes to it, depending on your application, but you'll get to see that it's very, very simple indeed. So first thing, we're going to select the file that we're going to play, and I'm going to play this file, WAV file 1 I called it. So we're going to pass a path to this file there. Okay, and that's it. And then I want to start playing this file. So I'm going to call a function called play. So this will just initiate the player. It's not going to play continuously. So you need, after you call this, you need to call another function called process. So WAV process is the one that will continuously check if there's something to process in the WAV API. And you can see the implementation of it is quite simple, really. If the state is normal, then it's going to swap buffers and or stop if it's at the end of the file, or remain in idle state if there's nothing to process. So into your while loop, so that corresponds to placing this process into your while loop in your application to constantly monitor for something to process. Okay, so I'm going to call it here. However, I want to call the process until the end of my file. So I'm going to put it into a while loop here. There's a function called isFinished. So if the file is finished, so end of file. So if it didn't reach the end of file, it will keep in the while loop. So if it's not end of file, then carry on and continue processing the WAV file. Okay, so this is the function we're going to call here. And now, while I'm in the infinite while loop, if my push button is pressed again, I will implement pause and resume. So I need to check for this condition again. Alright, so if my push button is pressed while the file is playing, then I want to either pause or resume. So let me use a simple variable called toggle. So I'll call it pause resume toggle. So this will switch between either we pause or resume based on the state of this variable. So I'm gonna, whenever this button is pressed, and then I will toggle this variable. I'll do an XOR, which will change the state from 0 to 1 or 1 to 0 accordingly. Now, if this one is high, then I want to pause. If it's low, then I will resume. Okay, so let me copy the code from my note. It's very, very simple indeed. So there's a function called pause in my WAV player. Here it is. So pause and resume. When the button is pressed, then I do a pause, and then if it's pressed again, then I will do a I'll do resume, except while it's in the well, let's not overcomplicate it. Let's make it very, very simple now. So this is what I said I'm gonna do. It resumes, and I will bring the red LED back to low. So this will light up the red LED whenever we pause, and when you resume, red LED goes off. Now, an additional thing that I want to do is that before we resume, if the button press wasn't a simple press, if it's a hold, then I will completely stop playing the file. And we do that by doing something like this. So I'm going to put a delay here of half a second. If we press the button more than half a second, or maybe let's make it 1 second for simplicity. If we press it for more than 1 second, then it's going to stop the file. So let me see. So if after 1 second the button is still pressed, then I want to stop instead of just resuming. And this only occur in while the music is in the pause state. Okay, there we go. And that's it. That's pretty much it. This is our demo. And towards the very end of the condition, so at the end of the while loop, so when we finish doing that, I want to switch this LED off. There we go. So when we exit that while loop, the player while loop, I will turn the orange LED back off. I'll put a short delay of 1 second so that we don't keep the button pressed mistakenly. So what's going to happen now is that when you press button, it plays, press it again, pause, resume, hold it, it stops. So press again, it plays. So let's demonstrate that then. Let me compile the code, load it to the board, and we're going to have a look at the board, and we're going to hear a very exciting music at the headphone. Alright, excellent. We've heard audio at the output. And now before I finish off the video, I want to make a few notes for you. This demo is based on 16 bits bit resolution. So what you want, if you want to make sure all WAV files you have will work, is to use one of these WAV converters. I quite like this one, audio to online convert. So what you can do with this is that convert any file format to WAV. And what you want to do is that you want to change bit resolution, ensure that it's 16-bit. So with this demo, only 16 bits work. Otherwise, if you want to play specific 24-bit files or 8-bit or 32, you want to make some changes to the I2S frame format. So you use one of these frame formats and also change DMA data width. And your audio frame buffer. So these are the kind of changes you want to make when I play other format. But for simplicity, I kept it constant. So just change any file you have to 16-bit resolution, a WAV file, and it will play out very nicely. All right, this brings me to the end of this video. Thank you so much. If you enjoyed it, don't forget to hit like and subscribe, and stay tuned for the next videos. Thank you.